My name is Gabriel, and today I'll be talking about absolute value for SLAM tutoring. So, what is absolute value, in case you do not already know? Absolute value is denoted by straight brackets and numbers inside of these brackets, and it makes whatever number is inside positive. So it will turn a negative number into a positive number, or a positive number just remains positive. So if you guys want to take a moment to practice this, if you're new to it, go ahead. Here are some practice problems, very straightforward. If you want to pause the video now, do it, and I'll show the answers now. You'll notice we get the answers right here. Negative 3 becomes 3, 5 becomes 5, negative 6 becomes 6, 2 becomes 2, and negative 8 becomes 8. So once again, really, it'll just turn all of our negatives become positives, and that is it. So, algebra with absolute value. This is where things get interesting. Now, absolute value is special because for you could plug in two numbers into the absolute value and get the same answer. For example, in this scenario, we have x plus 1 is equal to 2. And if we put 2 inside of the absolute value, we get an answer. We get this is true. If we put in negative 2, it's also true. So we have to solve for both of these scenarios because there's actually two answers for this. So what we do is we're going to set x plus 1, which is inside the absolute value, equal to 2, the 2 within this absolute value, and x plus 1 is equal to negative 2 inside of this absolute value. So we're working inside of the absolute value now, trying to find our two potential values that work, that give us the right answer. So from there, it's just super basic. You just have two different equations, and you just work these out. Subtract 1 from each side on both of them. X is equal to 2 minus 1. X is equal to 1. X plus 1 is equal to negative 2. Subtract 1 from each side, so we get x is equal to negative 2 minus 1, and x is equal to negative 3. So these are our two answers for this absolute value equation. Here is some more practice on absolute values. If you guys want to take a moment to pause the video to work these out on your own, go ahead. And I'll show how to solve these problems now. So first thing is to isolate the absolute value all on its own, because right now it's being multiplied by 3, so we have to divide each side by 3, and we get x minus 2 is equal to 2. Absolute value of x minus 2 is equal to 2. Then we have to identify our two potential answers. We could have negative 2 or 2 inside the absolute value, both give us 2. And then from there we set x minus 2 equal to negative 2 and x minus 2 equal to 2. We will then add 2 to each side of the equation to get x is equal to 0. And then on the other equation, we will add add 2 to each side once again to get x is equal to 4. Our next equation is already isolated, so we just instantly can identify our two answers. We could have negative 3 equals 3, or we could have 3 equals 3. Absolute value of negative 3 equals 3. So from there, we set 2x minus 1 equal to negative 3 and 2x minus 1 equal to 3. First step is to add 1 to each side, so we will get 2x is equal to negative 2. Then we can divide by 2 on each side, and we can get x is equal to negative 1 as our first answer. The next answer, we have 2x minus 1 is equal to 3. We will add 1 on each side to cancel out the 1 here, and then we will get 2x is equal to 4, and then divide by 2 on each side to isolate our x, and we get 4 divided by 2 is 2, so x is 2 and x is negative 1 are our two answers. And finally, we have absolute value graphs. So the parent function for absolute value, very straightforward, y is equal to the absolute value of x. Now, what this looks like is we can have any value for x. We can have positive values, we can have negative values. But because absolute value turns any number positive, that means the negative values for x are also positive. So basically, you'll notice we have, when x is 1, we have 1. But when x is negative 1, we have positive 1 for y. So that's just the absolute value making it positive. So what it looks like, the graph will never go under the axis because it just bounces right off. The absolute value will make it positive. The only way that an absolute value function goes under the y-axis into the negative area is if the graph is shifted downwards. For example, if the graph is translated downwards by an amount, then it can potentially go under. So here is another example. I'd like to point out that absolute value graphs are identical to the standard linear graphs. For example, we have 2x plus 1, which looks, as you may have seen this function many times before if you've worked with linear graphs already. You can see it just has a slope of 2 and it's shifted upwards 1. the absolute value graph, if you cover the negative part of the graph on each graph, it looks identical from the in the first quarter of the graph. Both graphs look identical. However, when it becomes negative, the absolute value graph, the slope gets reversed and goes straight up. So the absolute value just is making everything positive. And that is it for today. Thank you for watching.